welcome back to another video, and in this video we're going to be continuing on with our UIKit tutorial series, and in this particular tutorial we are going to be taking a look at how we can send post requests to an API using Swift for iOS. Now, in the previous videos, we took a look at GET requests and delete requests. This video is dedicated to post requests. Now, what is a post request? Well, a post request, much like GET and delete, is another kind of HTTP request where post is the verb, the HTTP verb, and semantically, a post request is intended to be used to create a new record or resource on the server. So when you send a post request, you're going to send the server a body of data in the request body, so it knows what data to use to create that new resource and potentially how to create it, right? Now, post requests are configured slightly differently than GET and delete requests, and we'll get into that in this video. One thing to keep in mind too is that post requests work identically to patch and put requests. In the next video we'll take a look at patch requests, which is a kind of updating request, but that we'll save that for another video. So let's go ahead and get started. So inside of Xcode, I have already created a method for creating a new project. Now, since the last video, I've updated the API. All right, so pull down the latest changes to the GitHub repo, and then make sure all that's up to date by pulling down the latest changes. If you want to use that, and then we'll continue on here. Pretty much the only change that I made to the API is that all the naming is now consistent, to make it a little bit easier on the brain as we go forward. So let's go ahead and inside of our create method, the first thing that we need to do is we need to create a URL object with the endpoint that we want. So the endpoint that we want is localhost 8080/API/project/create. So we'll say guard let URL equals URL with a string of http://localhost 8080/API/projects/create. All right. Next, if this was unsuccessful, we will simply return. Okay. Okay, cool. After that, we need to create our JSON encoder, and then encode the data, our Swift object, to JSON data, because our HTTP body is going to be a data object. So that's where JSON encoder comes in. We'll say let encoder equals JSON encoder, like that. Let data equals encoder.encode, and we need to pass it project. We'll save that. Now that we have our data, we can create a URL request object. So var request equals URL request, pass it our URL like we did with the delete request. But this is where things differ. The first thing that we need to do is we need to set the method that we're going to use. So request.http method equals post. Then we'll set the body of our request. So request.http body equals data, like that. Next, we need to set the content type header for our request, and this is important. We need to set the content type request header because our API handles JSON, and it needs to know what kind of data it's dealing with. If you don't include the content type, it's not going to be able to handle it properly, the server. So we'll say request dot set value. Now the first parameter here is the value that we want associated with the specific header. In this case, we want application/JSON inside of quotes. And then the second parameter is the name of the actual HTTP header. In this case, it'll be capital C content hyphen capital T type, like that. Now that that is completed, there are two things we need to do. First, we need to actually send the request to the server and then retrieve its response, leave its data ignored, but we need its response. And then we need to check the response status code. Now, why do we need to check the status code? Well, the reason why we need to check the status code is because not all issues with our network requests are caught by throwing an error. Sometimes the issue is on the server itself, and then it'll send back an undesirable status code. And when that happens, you need to be able to react to that and let the user know that, hey, something went wrong, and it may not be their fault, right? So to do that, we'll be using HTTP URL response. The response object we get back from URL session data is a URL response object, so we need to cast that. And we'll do that here in a moment. So let's go ahead first and send our request to the server by saying let underscore comma response equals URL session dot shared dot data for request. Now we have to mark this with try and await, like that. So let underscore response equals try await URL session dot shared dot data for request. Now that we have that response object, we can say if let HTTP response equals response as question mark HTTP URL response. So if we're able to successfully cast it, we can then check the status code, because URL response does not contain a status code, but HTTP URL response does. So we'll say if HTTP response dot status code is not equal to 201, then we want to throw some kind of error. Now, why 201? Why that specific code? Well, that specific code is being checked for because in the API we are returning a created response. And the status code for HTTP created responses is 201. Whereas 200 is okay, 204 is no content, so on. I don't remember all the codes off the top of my head, but I remember those in particular. All right. So if the status code is not 201, we know something went wrong. We can throw network error dot creation unsuccessful. And there we go. I see. We need to mark our encode call with try. I completely forgot to do that. So let data equals and try encoder dot encode. All right, that is our networking code to send a post request to the server. Let's kind of go over what we did here real quick. We're gonna breeze through this explanation here. So we've created a method called create. It takes in a project object, so the project we want to create on the server. Then we are creating the URL so we know what URL to send our request to. Then we encode our project object to a JSON data object that we will then attach to the body of our URLRequest object. We set the HTTP method to post. We set the content type header, a request header, to application JSON, so our server and our client speak the same data transfer language. And then we send that data to the server. After we get the response back, we check our status code to see if it's 201. And if it's not 201, we throw a network error because we know something went wrong. All right, cool. Now, inside of our project screen, we can actually use this method. So let's go into our project screen. Okay, so I was doing some practice here. Let's get rid of this here. Okay. All right, so inside of the action method for an add button, what we're going to do is we're going to enclose everything in a task. So we have an asynchronous context to work with. Because remember, action methods for buttons aren't asynchronous by default. They are synchronous. So we have to kick off an async task, some kind of asynchronous work from an async context, which is where a task will come in. So the first thing that we want to do is we want to get the name of our project. So guard let name equals project name field dot text, else return, because the text property of the text field can be nil. We want to make sure that we safely unwrap that. Next, we will say let project equals project. It takes in an ID, so UUID. We pass it a name. And then we pass in show closed to make sure that this is marked as either active or closed, depending on what tab we add the project in. And then we pass it an empty array of bug report. Typically, you will have a separate model for sending post requests as opposed to getting, get requests and stuff like that. But I didn't do that here. We're keeping it relatively simple. On the server, the array isn't, it doesn't do anything on the server. The array of bug report objects is specifically there for GET requests. All right, so now the next thing we need to do is we need to actually send the request to the server by kicking off our create method in our network manager. And we can do this by saying do, and we need to attach a catch block to this. Okay, so inside of the do block, we will say try await network manager dot shared dot create project. If we have successfully created a new project on the server, so if by this point we haven't crashed or thrown any errors or anything like that, we can say self.projects.append project, and then we'll apply a snapshot to our data source for our table. So it'll refresh and do what it needs to do there. However, when we catch an error, something needs to happen there. And what we'll do is, instead of, crashing the server or something like that, or rather crashing the app, what we'll do is we'll print error.localized description. We'll simply print the localized description of the error. Nothing will happen. Now, you typically don't print the localized description of an error in a real-world app. This is usually used for debugging, but in a real-world app, you will typically summon an alert of some kind for the user to see, letting them know that something went wrong with creating the object. And you might use a localized description of your error if it's a user-friendly error. But other times you might not use that and have some other user-friendly error message. Now, we're not going to use an alert here because we haven't learned how to use those yet. All right, so we can save that code. And we should be good to go. Let's save this, run our code again. We have a successful build. So here we are. Our active projects table is empty. Same with the closed projects. So let's add a project to the closed tab here. We'll say project 1. We'll add that. And there is our project. Let's go to our Active Projects tab. This table is empty, as intended. Let's say project 2, add. And now we have our project 2 inside of our table view here. When we close out of the app and we run it again, we can see that the data persists. Alright, so that pretty much does it for this video, guys, on how we can send post requests to a third-party API in Swift for iOS. Thank you all so very much for watching, and we'll see you in the next video.